Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum and selamat hari raya everyone. Today we from group 5 will be conducted a presentation about chapter 6, which is aromatic compounds. In our group, in our presentation, we only have two topics, which is task 1 and task 2. Our member consists of 3 participants. The first one is me, Muhammad Hakimi bin Yunus. Next is Muhammad Zikri Fahmi bin Muhammad Zamri. And then last is Muhammad Azimuddin bin Mazuha. For the task 1, it will be conducted by me, Muhammad Hakimi bin Yunus, and Muhammad Zikri Fahmi. And for the task 2, it will be conducted by Muhammad Azimuddin. So let's go to the task 1, which is answering questions. For our presentation, we have 4 questions. So the first question is, by using appropriate equations and stating the type of mechanism involved, explain why benzene is less reactive than cyclohexene towards chlorinations. Okay, in this question, we can know that the question is asking us about the equations and type of mechanisms, and when we want to compare the benzene and cyclohexene, we must use the chlorinations process. So the answer is, for benzene, type of mechanism is electrophilic aromatic substitutions, and general reaction for chlorination of benzene is firstly is we have benzene and we add with the chlorine, and we use ferrum chloride as the catalyst, and we get the. For the cyclohexene, type of mechanism is electrophilic addition mechanism, and the general reaction for chlorination of cyclohexene is, firstly we have cyclohexane when we add with the chlorine, and we use chloromethyl as the catalyst, and in the dark condition, and we will get dichlorocyclohexane as the product. Dichlorocyclohexane as a. So for the explanations, benzene is less reactive than cyclohexene towards chlorinations because benzene has 6 decollized pi electrons distributed over the 6 atoms of the ring. This makes the electron density in benzene lower and make it tougher for any molecule to make an attack.
Benzene can undergo further Kraft oxidation with ethanol chloride to form compound A. Write the reaction equation and show the reaction mechanism, including the formation of resonance structures for the uranium ion. Name compound A. For the answer, reaction equation, benzene will react with ethanol chloride. With the catalyst AlCl3, we produce compound A, which is 1-phenylethanol. Next, for the reaction mechanism, step 1, generation of electrophy. Okay, so the Cl will be negative, and the negative part we take by the Cl3. So we are going to have acetyl positive attached to AlCl4 negative. Step 2, formation of uranium ion. Okay, this structure will be react with the acetyl. So acetyl will attack the nucleophilic site. Okay, so the double bond here will be removed, and acetyl will attach here because it get 2 electron, and positive will be here because it losing 2 electron. Okay, next, the double bond here will give the electron to here, and the positive charge will be moved to there, to here, and it will be like this. So it's the same. The double bond here give 2 electron here, so the positive charge will be moved to here, to this part. So we get the new resonance structure like this, and the positive will be here. So the three resonance structure here will call also we call as uranium ion. Next, step 3, use of proton to reform aromatic rings. Okay, so the hash will be removed and the electron in the bond will move inside to make a double bond. So the electrophilic substitution will happen, which hash move out and the electrophile move inside. So we are going to have a product like this. Question 3. Compound A react with a hot mixture of concentrated nitric acid and concentrated sulfuric acid to form only one product. Draw the product produced. Explain why only one product is produced. Compound A, 1-phenyl ethanol, will react with a hot mixture of concentrated nitric acid and concentrated sulfuric acid, and it will produce M-methylphenyl ethanol. Next, why only one product is produced? It is because COCH2 is electron withdrawing group, which is a deactivating metal director tends to redirect the incoming group into metal position.
Question number 4. Next, suggest a synthetic pathway to show the formation of phenylmethanamine from benzene. So the answer is, firstly, we have benzene, and we use Friedel-Crafts acylations, and we add with the chloromethyl, and we use aluminum chloride as the catalyst, and we will get toluene. And we use halogenation of alkyl benzene with free radical substitution using the Br2 with the UV light, and we will get the bromomethyl benzene. And lastly, to get the phenylmethanamine, we use nucleophilic substitution with ammonia NH3 with the excess of NH3, ETOH, and reflux, and we will get phenylmethanamine with Br as the product.
Bismillahirrahmanirrahim. So we continue to our task B, which is nucleic component. So our functional group is carboxyl. Class of component is carboxylic acid. Chosen plant that we choose, which is pomegranate. Related Quran verse is Surah Ar-Rahman, verse 68, Surah Al-An'am, verse 141. The pomegranate Panica granatum is a fruit bearing deciduous shrub in the family Latericeae subfamily. As intakes, sarcotestes or juice pomegranate are used in baking, cooking, juice blends, milk garnishes, smoothies, and alcoholic beverages such as cocktails and wine. Pomegranates are widely cultivated from Middle East region, North and tropical Africa, Iran, and other more. So we continue with Quranic verse, which is defined in Surah Ar-Rahman, verse 68. فيهما فاكهة ونخل ورمان. In them are fruits and plums and pomegranates. In Surah Al-An'am, verse 141. وهو الذي أنشأ جنات معروشة وغير معروشة والنخل والزرع مختلفا أكله والزيتون والرمان متشابه وغير متشابه كلوا من ثمره إذا أثمر وآتوا حقه يوم حصاده ولا تسرفوا إنه لا يحب المسرفين. It is he who produced garden both cultivated and wild and palms and crop of diverse species and olive and pomegranates similar and dissimilar. Each of its fruit when it yields, and give its due on the day of its harvest. And do not waste, because surely he does not like the wasteful. So we continue to benefits of pomegranates. There are many benefits when we use pomegranate in our lives. As an example, I just leave a few. There are so many benefits pomegranate, but that's most important, which is protects us from free radicals. It's our blood pressure. It improves our memory and it's in our blood. So we continue the composition in pomegranate. The edible parts of pomegranate fruit represents sugar, moisture, sodium ion, pectin, magnesium, copper, amino nitrogen, and ascorbic acid. So active component in pomegranate that we found is 4-hydroxybenzoic acid. 4-hydroxybenzoic acid, also known as p-hydroxybenzoic acid (PHBA), is a monohydroxybenzoic acid, a phenolic derivative of benzoic acid. C7H6O3 chemical formula. It is white crystalline solid that is slightly soluble in water and chloroform, but more soluble in polyorganic solvents such as alcohol and acetone. 4-hydroxybenzoic acid is primarily known as the basis for the preparation of its ester, known as parabens, which are used as preservative in cosmetics and some ophthalmic solution. It is isomeric with 2-hydroxybenzoic acid known as salicylic acid. A precursor to aspirin, and with 3-hydroxybenzoic acid. 4-hydroxybenzoic acid is produced commercially from potassium pentoxide and carbon dioxide in the Kolbe-Schmidt reaction. It can also be produced in the laboratory by heating potassium salicylate with potassium carbonate to 240 degrees Celsius, followed by treating with acid. For example, chemical reaction in the pomegranate, 4-methylphenol will react with potassium permanganate that will undergo oxidation to produce 4-hydroxybenzoic that contain carboxyl group. The color from colorless solid to white crystalline solid. So here our reference when do this assignment. Thank you for watching our video. Assalamualaikum.